Okay, I will start. Okay, I will start my lecture again. So far in chapter 11, I have explained the two independent samples using t-test or z-test. It depends on sigma 1 scale or sigma 2 scales are known. If it is unknown and sigma 2 scale is unknown, two cases: equal variance or unequal variance. When you see, in this case, pooled standard deviation will be used. Here, unequal means degree of freedom will be adjusted. And then we calculate both will be when the t-test will be used. It's known, z-test will be used. And we have tested like that. But now, remaining the last one in chapter 11 is paired comparison. First, this and this is their pair. This value is we will compare. This person performs this element, it will be compared like a pair. Okay, and then we try to find out any difference exists between 2 points. We first in this case, for example, on this one is we will calculate is x1. Let's say y1, x1, x11, x21. I will say minus it will be d1. x12 minus x22 is d2. Okay, x13 minus x23 is d3. We will calculate difference. What is difference 1, difference 2, third pair, difference 3, difference 4. We will calculate, and then we will calculate average of a difference. D bar will be calculated. We calculate D bar. N is same. N1, N2 does not exist, just N pairs and standard deviation. Okay. For this one, we will calculate T1, T2 up to Tn. From here, we will calculate average of difference and standard deviation of the difference, SD. SD will be calculated, SD, T bar square root and the T value. This is T paired T statistics. It will compare the critical T value. Critical T value is relating to alpha. T value is relating to P value. Okay, then P value will be compared to alpha, or T statistics will be compared to critical T statistic. Degree of freedom is sample size n, the m minus 1 is degree of freedom. T bar is average difference. SD is standard deviation of the difference between. Okay, then TI, this is TI minus average and difference square. Summation divided by degree of freedom square root is standard deviation. Example is a nickel savings and loan employs two firms, Shedek Appraisal and Boyer Real Estate. Two appraisal company. This is one appraisal, this is Boyer Real Estate. Two companies. This bank is a nickel savings loan. This is our banking our company employ two evaluation firms. One is a Shedek Appraisal. Second one is Boyer Real Estate. To appraise the value of real estate on which it makes loan. Our customer come to us and to buy some real estate. request loan. To do it, we need to appraise the real estate. What is the value? So we cannot do that. So we will employ 2 appraisal companies. One is Shedek, another one is Boyer. Okay. And then 10 homes. So home 1, home 2. Here, Shedek and Shedek appraisal Boyer. They will give different number. Will be for home 2 different numbers. Up to 10 homes, Shedek and Boyer may give different numbers. So and then we want to know this value and difference, any difference exists or not. So this should be dependent on each other. So we need to subtract to try to calculate D1, D2 up to D10. So thus there will be a pair of values between appraisal variables. So home A, B, and J, Shedek, and you see, Shedek is appraised a little bit higher. When you see this one, yes, always higher. See, Shedek is a little bit more positive, and Boyer is a little bit negative. They look at it carefully one by one. Recall that Nickel Savings and Loan wishes to compare 2 companies in uses appraisal to value of 10 residential homes. Nickel Savings select a sample of 10 residential properties and schedule to both firms for an appraisal. All the number is this 245,000 is 000 is there, and significance level is 0.05 alpha. This is alpha. Can you conclude there is an difference? This difference, average of difference is not 0. It means there is a difference. 0 means there is no difference. So now alpha is 0.05. We will calculate T, and T star is like this. So it depends on, we total 10, sample size is 10, n-1, degree of freedom n-1 is 9. Degree of freedom 9. When you look at it, equal to 0 is 2 tails. 2-tailed question. Alpha is 0.05. We need to find out critical T value from the table. Here, degree of freedom 0.05, 2-tail. The answer 2.262. Okay, plus or minus 2.262 is critical T. This is T star. Our T is between plus or minus 2.262, H0. There is no difference, is accepted. If our test T, step 3, is beyond the range, bigger than 2.26 or less than minus 2.262, then we will reject. So we will need to accept H1. So once you understand the process, and then let's try to calculate. You see, we calculate is minus, they calculate, and this one average is 4.6, and this minus 4.6, and this minus this, and then take a square and try to calculate standard deviation 4.4. So to calculate this one, 3.3. So 3.3 is beyond the range. Range is 2.262. Okay, critical T is 2.262, so bigger than this one, so we will reject. H0 is rejected, alternative accepted. There is some difference. E, there is a difference. Dependent, independent. There are two types of dependent. Those characterized by measurement is intervention of some type and some other measurement. For example, suppose we wish to show by playing music in the production area. Playing music in production areas, we are able to increase production. This is your hypothesis. So we begin by selecting a sample of workers, measure the output. Then we place the speaker in the production area, play soothing music, and then we again measure output. So before, after. Before music is played, after music is played, we want to check the difference, but we will apply to same person. So this comparison is dependent, paired comparison. Okay, so this before and after, this is another possible. For before the music is applied in the x1, x2, xn. Before the after music is f21, f22. You see, f2n. We check the difference between them. Then before after some treatment is also it is a paired comparison. Matching or pairing observation. For example, nickel savings and loan examples. Dependent samples because a property is selected. Both firms appraised by the same property, same real estate is appraised by two companies. Okay, so it is a pairing dependence problem. We prefer this one is second case. This is same real estate or property is evaluated by two different appraisal company at the same time, but it actually there's no time difference. First case is time difference exists. Before after cases, but same person. The target is same, but before treatment and after treatment, you want to compare. Okay, we prefer a test based on dependent sample because it reduces number of amount of variation in test and consider a better test. Second case is much better, same time. But first case is also possible, but problem is before after is there may be many other factors may affect it only. Maybe before after we two same employee must do same thing, but you know before after is it may be there may be some there may be exist some learning effect. They may be physically condition is getting better or physical condition is getting worse, and it may affect on the result. Okay. Before after is you need to be very carefully designed about this one. Okay. So practical problems in question one. Question one in our textbook, page 353. Before that, I need to do the using Excel. Same question, okay? Nickel savings and loan is two is Shadek and Boyers, okay? In this case, you need to subtract this one. It's a D1, D2, D3, and we can calculate and so on, okay? Bottom one is maybe using Excel data analysis, data analysis. Here, t-test, paired t-test. Select this one. Click is this one is okay. This is up to here. First data variable 2. Mean difference is 0. We assume to 0. Labels yes. Is alpha was I forgot. For 0.05. So This is okay. And output range is selected or new worksheet and click it. Okay, then it will give you a result like this. And we have calculate this one, critical T from T distribution table and compare. This is bigger. So we will reject H0. They are different. From p-value is difficult to do it. So exact function is t-dist bracket t-value degree of freedom 1 tail 2 tail. So here I said t-dist J63 here. J63 is t-value bracket degree of freedom is 10 sample. 10 minus 1 is 9. Okay, it's 2 tail equal or unequal. So p-value is compared to alpha directly. This is smaller than this. So we will reject H0. That's one way. Another way is you can use megastart. Megastart here, when you click it, it's paired comparison here. Data, yes. Data input first. Second, hyperset difference is no difference. So it's equal or unequal. 1 tail 2 tail, it depends on is equal 0, unequal, so unequal is unequal 0. This is t-test, and this is correct. Okay, point alpha is 0.05, so 95%. Click OK, and then you will have this result. P-value. T-value will become T star. P-value is 0.002. Same thing. I already mentioned this one. Same number. This is smaller than 0.05. So we will reject H0. You can calculate in this way. I will save. Now, move the question 1. A sample of a 40 observation is selected from one population with a population standard deviation. Standard deviation 5 is known. If 5 is given one population. And sample mean X bar. This is for sample of population 1. Next is a sample of 50 selected from second population. This is another population. Okay. Mu2 is 99. Sigma 2 is 6. 5 and 6. Average is 102 and 99. We want to know and 0.04 significance level. Okay. Usually such a number is not used. 0.1, 0.05, 0.001, 0.01 is popularly used. So we want to test the equal one. Exists any difference? Is unequal, so it's two-tail test. Reject comparison is we need to find out media. Forgot. At the end of it's not here. I want to show the let's save. Normal distribution table, t-test, and so on. We need to have some table. Okay. Question 1 is there. And so it's alpha was it's normal. See, t-test, just to test the two things. N1 and 2, you need to write down, okay? N1 is 40 and 50. You need to, S1 is 5 and 6. X1 bar, X2 bar, 102, second one is 99, right? So jet value is will be calculated. Sigma is known. You're not S, this is sigma. This is sigma. So we will calculate like this. Jet value is okay. We will calculate 2.587. This is okay. Then alpha is 0.04. We need to find out how do we get this number from the table. Let's try to Excel. Normal distribution table, where is it? I have used it here. The table. Okay. Okay, I will copy it to the Excel file. Okay, I will put everything in here. The first one is normal distribution table, and then copy T table. So we need these two, okay? I need to compare these two tables and background, and then I'll go back to problems. Okay. From current. Okay. It's much easier for me to show. Okay, I'm here. So we have calculated this one. It is alpha was 0.04. Previous case is it is there. N1 and is equal to the total. So we need normal distribution table, standard normal distribution table, 0.04, right? So that was so here in like two table. This is 0.02. This is another 0.02. So this means this area is 0.48. 0.48. We need to find out 0.48. 0.48 is here. Between the first 2.25, 2.5, 2.05. This one is 2.06. Between these two numbers, between 2.0, 2.05. You see, so they counted 2.05 and 2.06, and so 2.05 and 4. Just start is calculated from the table. Or you need to calculate using normal Excel function. We calculated 2.5 is outside, is bigger, so we will reject. When you use the p-value from the, we need to calculate backward. You need to remember this one, 2.587. Okay, 2.57. I will erase this one. $2.587. 2.5 8 7 between here. Your textbook is like, okay, 0.49. So the remaining is 0.05 or 0.08 and so on between them. Okay. And multiplied by 2. 0.0048 is around, from the table I have read around this one, but correct number is 0.0048. Okay, so just subtract this one and multiply by 2. The two-tail problem. The p-value is, then p-value will be compared to alpha. 0.04 is smaller than, so we will reject H0. Same thing. Problem 7. So when you read the question, you need to find out what type problem is it. You need to distinguish them now. First one is, okay, two groups, but sigma is known. So we will use z-test, two-tail problem. What is alpha is 4%, okay? If you know the what type problem is it, is much easier. Question 7, random sample of 10 observation of one population. So N1 is 10. Sample mean of 23. X1 bar is 23. Standard deviation, sample standard S1 is not sigma, this is S4. Random sample 8 from another one is, and 2 is 8. And blah blah, sample mean X2 bar is 26. S2 is 5. This is sigma is unknown. Sigma 1, sigma 2 unknown. So we will use t-test. T-test. And same equal variance is unknown, but equal or unequal, we need to check it. Significance level alpha is 0.05. Is there any difference between the population mean? So it's equal or unequal variance. We need to find out. So there is no specific explanation is there. Random sample of 10 observation of one, another 8 observation from another one, but there's no information about equal or unequal. So in this case, we need to test the F-test to equality. So The degree of freedom is, if it is equal m1 plus n2 minus 2, this will be degree of freedom. 10 plus 8 minus 2 will be 16. Degree of freedom will be 16. Degree of alpha is, if it is equal, okay, so 16, alpha is 0.5, two-tail problem. Two-tail, this one. Two-tail, we need to look at this one. Point 0.5 around this column, and 10 plus 8 minus 2 is 16, so we need to look at 16th. This one, 2.12. 2.12. We read this number, 2.12. 2.12 will be 2.12. Okay, this is critical. T star minus T star. Bigger than T star or less than minus T star, we will reject. Between them, we will accept H0. So the pooled variance. The formula like that. We calculated T, we calculated, and then this number has been used here. So this is between minus 1.416, between 2.12 greater than minus 2.12 is accept area, so cannot reject. Or using this one, 1.416, we need to calculate p value. Okay, from the p, t is minus 1.416. 1416. When you look at 1416, around here, 1416 is around here, and then p value is between 0.1 and 0.2. 0.1 and 0.2. Exact number is 0.1752. So they may use the Excel function. From the table, we cannot read accurately. Okay, so this is bigger than 0.05. So we will accept H0. Question 15. A recent survey compared the cost of, and also here is there is no explanation here, so we assume equal variance, but here there is no test is given in the problem solving. But when you use Excel, it's better for you to do some F-test, or when you use Megastat, select and test of equal variance or not. Okay. Question 15. A recent survey compared the cost of adoption through public and private agencies, cost of adoption through public, cost adoption through private agencies. For example, 16 adoptions through public agencies, the mean is like that, and standard deviation. A sample of 18 adoptions through private is private agencies, average standard deviation. Assume the sample population do not have no equal, so this is unequal variance. Alpha is 0.05. Determine degree of freedom. In this case, degree of freedom calculation is more complicated. Look at the formula. And then you need to through the decimals. Do not round up. Round off is 26. You need to 26, and then you calculate t value, degree of freedom, then t star. You get 26 and degree of freedom. And what is alpha? Alpha is 0.05. So let's look at 0.05 is greater than or equal. This is one tail problem. One tail, 0.05, and 26 degree of freedom. Let's look at. So I will erase this one. $26. One tail, 0.05 is here. You're going down, the answer is here, 1706. 1706. This is T star. Our calculated T value is this one. Greater than T is greater than 1.706. This is T star. Calculate T. So we will reject H0. So we find evidence indicating the mean cost at private agency is more expensive. One more question, 17. Null and alternate hypotheses are, so it means the following is a day 1, 2, 3, 4, day shift, after shift. The following sample information shows the number of defective units produced on the day shift and afternoon shift. Of sample of 4 examples. Day 1, same day shift, afternoon shift. Day 2, day 3, day 4. Assumption is, so when you it look like increasing. Day 4 is they may produce more. We cannot compare like this. But the same day, same workout. So we can compare like this. It's a paired comparison. And paired comparison, whether any T1 is 10 minus 8, 12 minus 9 is T2, 15 minus 12 is T3, 19 minus 15 is T4. If we do that, the average is in population, average of difference is greater than 0 or less than 0. Greater than 0 means in day shift is maybe it look like produce more defective. Afternoon is less. So I don't know. It's a day shift is maybe some people they drink a lot in the previous day evening. You know, they're tired, and the day is morning shift is maybe some problems. Okay, what is p-value? What is null hypothesis? Rejected, and what is conclusion and so on. So we need to say what is 1, 2, 3, 4. N is 4. Degree of freedom is 3. And p-value, it doesn't say anything about sorry, alpha is not given, you know, alpha is not given. So we will calculate directly. DS average is so T1 is, I will erase this one. this one. T1 is 2, T2, 3, T4, 3, T4, 4. I will calculate the average SD. SD is standard deviation of this. Sample standard deviation. So average D standard sample standard deviation is okay. So average divided by SD divided root N. So we calculate this one. So up to here, we try to calculate p-value using degree of freedom is 3. T 7.34a. Degree of freedom is 3. Using this assumption, try to find out p-value. Okay, look at degree of freedom is 3. So when you look at this, we will look at this number. We'll look at here. So when another one is 1 tail, 2 tail, we need to find out when you look at this. Greater than equal to 1 tail. 1 tail problem. Okay, 1 tail problem. So we will look at this one. Okay. And then again, 7.34a, 7.34a, 7.34a. Between here. So between here, and we're going, our p-value is between here, between 0.005 and 0.001. Between them, the p-value is 0.0026. How do they calculate correctly is they will use Excel function. .0026. Then we, alpha is not given, so we may say 0.0026 smaller than 0.05. So at 5% significance level, we will reject H0. So, and also 0.01 smaller than at 99% confidence level, we will continue to reject. Okay, so whatever the alpha it is very, very small p-value. So we reject H0. Part D. What is the conclusion indicated by the analysis? Indicate is there are more defective parts produced in day shift. In day shift, create a lot of, it looked like only 2, only 4, but 2, 4 compared to standard deviation, one standard deviation is 0.8, but actually is 2, 3, 4, 8 is more than 2 standard deviation, 3 standard deviation, and so on. The day shift may have a lot of problem, okay? But we find out there is a static analysis. Yes, day shift has some problem. But why that happened? The causes we do not know. Because many people is drinking last night, or sleeping, they didn't sleep well, or some other problem. Maybe manager is in factory is too soft and is not very strict person. That's why maybe such a result may happen and so on. The next question, why did it happen, is different issue. Okay, in this way we count. I will summarize this one. Here, chapter 11 is two independent t-test or z-test, okay? When sigma 1, sigma 2 is known, is unknown. Unknown, there are two cases, equal variance unequal. So there are three cases. Z-test, both are known. T-test, when under assumption of equal variance. Another one is t-test under unequal variance. Paired comparison, if we have a 1 by 1, then D is equal to 0, 1. We want to test this one. Okay? So we may have such a problems, such a cases in chapter 11. The next one is, I have mentioned this one, chapter 12. Next week is 3 groups, group 1, group 2, group 3. In COVID-19, for example, which vaccine? Pfizer, Moderna, Janssen, another one is what is AstraZeneca or Chinese brand, and we want to test which immunization vaccine is more effective and so on. More than 2. In that case, we will use ANOVA test and so on. One of them is we may use placebo is a control group. We didn't do anything, but patient, they do not know. Patient have some, maybe some vitamin, injection and so on. They didn't understand what that difference. And then only experimenters only know what each, which customer patient will have which injections and so on. And then we will monitor about 1 month later, 2 months later, and so on. We will check it. Their antibiotic groups, how many antigroups are generated, and so on. Okay. I think it is the end of this chapter 11, and homework is homework for chapter 11. I will upload this evening. Okay, I will find out, and then I will upload that one. Okay, wait a minute. I need to check your attendance. Okay, check is save attendance. Yeah. Okay, I have saved your attendance. Okay, see you next week. Next week, I will move to chapter 12. Please read the chapter 12. It's more complicated, okay? My target is up to chapter 13. Chapter 12 and chapter 13, and then you will have final exam, okay? Before final exam, I'll try to give you some last review session and so on. I hope you may follow all my lectures and so on. If I were in Phnom Penh, it's much easier for me to give you my feedback and so on. But my lecture is only available through internet only. But I hope all of you may follow my lecture and try to study your best, and then have a good result in final exam. Okay, any question regarding today's lecture?
Professor,
No?
can I ask you how to find the p-value of t-test from the
how to calculate p-value, right?
Yes.
Okay, in the t-test, I will use anything, okay? For example, I will use the homework problem solving like that. What is p-value? Question 1. Okay, I will do it again. This is z-test. So using Excel is easier. You can calculate directly, okay? But this one is So p-value, let's say like this. This is half alpha, Z star. Another half alpha minus Z star. The critical Z, the Z star is relating to alpha. But we calculate Z value, and Z value is corresponding to P value. We need to read the table backward. Our test statistic is 2.587. You remember this number, 587, 2.587. Normal distribution. So I'm erase this one. The normal distribution table, so we will use left this table. Z value is 2.587. Am I correct? 2.587. 2.587. Between these two numbers, what are we? That was another year 2.587, but 2.58 is 0.49551. 2.59, 0.492. Okay, so the 2.587 between them, we need to calculate, So you need to look at the table is 2.58, 2.59, here, 2.587. It is 0.4951. Here, 0.4952 is assumed linearly increasing. Among here, what is here? You need to read this number. This triangle, the bigger triangle is the ratio is the same thing. So the difference is 0.0001 multiply 0.7. So it means 0.00007. Okay, and then we will be added here. No, some is 0.00. Only 0.0001 multiply this one 0.00007. So what value is 2 point is point is 0.4951 something. Okay, so linearly we can use it. And then why it is p-value is 0.0096, because the table shows this number 0.49. 4951. And then subtract this one and two-tail problem, multiply 2, and you will have this one. So this value, and we calculate this one is t statistic minus 2.5 is here, 2.587 minus 2.587 in this and this. That's why we calculate by 2. 0.5 is right half. 4952. That simply is the 4952. They use these numbers. Okay. Roughly, just they use the approximation 4952. Or you need to use for this one, instead of this one, you need to use integration. Integration 0 to z star, z value, your normal distribution function name integrate. Okay. This integrate is done by computer, Excel computer. Excel computer will calculate z distribution. Okay. I have mentioned already this one. Examples are like this. How to calculate norm dist. Norm dist shows everything like this. And then to calculate this one minus the shaded area is this is p-value in one tail problem. Two tail is you need to another half is the left hand side. Try to figure it out the problem. When you solve the assigned homework problem will be assigned late this night. Tonight I will copy and questions and upload it, and I will let you know what is your homework problem. When you solve the problem, you need to find what is p-value in manually or computers, T-value is the same. T-value is more complicated. T-value is the p-value is T distribution. T distribution indicates degree of freedom unit. Degree of freedom is 16. Significance level 0.05. And T statistics, you need to find out T. So it's almost approximate like this. This is minus T, the plus T is 1.41 minus 1.16. This is plus 1.416. Okay. P-value is this is p-value, also this is p-value, but this is when you look at the one tail, two tail problem, you need to read carefully. Okay, it is two tail problem, so p-value is this is half of p-value. P-value divided by 2. This is p-value divided by 2. So this value will be given by the computer and then TV. Also, when you use this table, this is from 0.05. You see, so when you look at the you need to look at the point. Your z value is t value 1416. 1416. We need to read the table. Z value 1416. 1416. When you look at 1416 here, 1416 is maybe around here. When you go down to, when you down 1416 there, just degree of freedom you need to read carefully. Degree of freedom in this case 16. 16. One four 16 is between here, right? So two tail problem between here. So when you do linearly interpolated, the p-value is between there in two cases. So is p-value is greater than 0.1, less than 0.2. You see, greater than 0.1, less than 0.2. Between that, The exact number is, if you want exact number, is we need to calculate. Okay. Anyway, the p-value is greater than 0.05. So you will accept H0. You don't need the exact numbers. Is that okay?
Yes, sir.
Yeah. And try to solve your homework problems. Homework problem will be posted late this evening, okay? I have checked your attendance and you may leave now. Okay, see you next time. Okay, see you.
Bye bye, sir.
Bye-bye.